The sun was just rising over Kennedy Space Center when the first steel beams for the new... It is hard to grasp the scale of what is happening in Florida right now. You are looking at a structure that stands 469 feet tall. That is taller than the Statue of Liberty. It is built from steel sections that weigh hundreds of tons each, and it is not just a building, it is a machine. This is what SpaceX calls Mechazilla. It sits right at historic Launch Complex 39A. This is the same ground where Apollo 11 launched to the moon. Now it is home to something much bigger. The goal here is simple but aggressive. SpaceX wants to turn space travel into something that looks like air travel. You have seen rockets launch before. You know the drill. A rocket goes up, maybe a booster lands, and then you wait weeks or months for the next one. That old way of doing things is over. The new plan is about speed. It is about launching, catching, refueling, and launching again. And the numbers proving this are real. The Federal Aviation Administration released a draft report in 2025 that tells the whole story. This is not just hype, it is a government document. It says LC-39A could host up to 44 Starship launches per year. Think about that for a second. 44 giant rockets launching from one pad. The report breaks it down even further. It counts 44 booster landings and 44 Starship landings. Split it evenly between day and night. 22 daytime launches, 22 nighttime launches. This is a plan for a factory, not a science experiment. Regulators studied every part of this. They looked at noise, they looked at wildlife, they looked at how often a rocket would blast off. That comes out to roughly one launch every 8 days from a single pad. Nobody has ever operated a rocket this big at that speed. The Saturn V launched humans to the moon, but it only flew a few times a year. The space shuttle was supposed to be frequent, but it never got close to this. SpaceX is building a system to do what NASA dreamed of in the 1970s, but could never afford. But LC-39A is just one piece of the puzzle. Nearby at Cape Canaveral, there's another site called SLC-37. This used to be the home of the Delta IV Heavy. Now the Air Force has approved it for Starship too, and the numbers there are even crazier. The approval allows for up to 76 launches a year. It also counts 152 landings. That means boosters coming back and ships coming back. If you add it all up, Florida could see over 120 Starship flights a year. That is almost one every 3 days. This changes everything about how we get to space. It turns the Space Coast into a true spaceport. You can see why this matters. It is about moving massive amounts of cargo into... It is about building stations, fueling depots, and eventually ships to Mars. You cannot do that with one flight a month. You need a rhythm, and that rhythm requires infrastructure that can handle it. That brings us back to the tower. Building Mechazilla was a massive challenge. You cannot just drive 400-foot steel sections down the highway. The bridges are too low, the roads are too narrow. So SpaceX had to get creative. They built the sections in Florida and Texas. Then they used barges to move them. They floated these giant pieces of steel 2,300 miles across the Gulf of Mexico. This was a logistical nightmare. The route went through the Gulf Intracoastal Waterway. It is narrow and tricky. The barges move slowly. Tides change the water level. Wind pushes the high steel structures. Engineers had to monitor everything. One bad gust of wind could tip a barge. One mistake at a bridge could block the whole waterway. But they made it work. They delivered the segments to the Cape and stacked them up. The assembly itself was a precision job. The tower has to be straight. If it leans even a little bit, the catching arms won't line up. The arms are the chopsticks you see near the top. They are designed to grab the booster out of the air. This is where the engineering gets really interesting. A Starship booster is huge. It is 230 feet tall. It comes back from space falling at hundreds of miles per hour. Catching it sounds impossible. Most people thought it was a joke when they first heard about it. Why not just land on legs? Every other rocket lands on legs. The lunar module had legs. The Falcon 9 has legs. Here is the secret to how they realize that legs are heavy. They add weight to the rocket. That weight eats into the fuel and cargo you can carry. If you put the landing gear on the tower instead of the rocket gets lighter. A lighter rocket can carry more satellites, it can carry more fuel, it becomes more efficient. So engineers move the complexity to the ground. The tower is heavy and strong. It has sensors that track the booster with millimeter precision. When the booster falls, the engines fire to slow it down. It hovers for a second, then the arms swing in and grab it. This saves tons of weight on the flight vehicle. It also speeds up the turnaround. You do not have to inspect landing legs. You do not have to fold them back up. You just place the booster back on the launch mount. Then you stack a ship on top. Then you fuel it. Then you go again. That is the magic trick. It turns a weeks-long process into something that could take days or even hours. You have felt the frustration of watching delays before. A valve sticks. A sensor reads wrong. The launch is scrubbed. You wait another week. This new system is designed to eliminate those bottlenecks. The tower handles the stacking. It handles the fueling. It stabilizes the rocket against the wind. It is an all-in-one service station for the biggest machine ever built. The construction work at LC-39A reflects this new speed. Crews returned to the pad in the summer of 2024. They had paused for a while, but then they hit the gas. They built the launch table off-site. This is the big steel ring the rocket sits on. They built it at a place called Roberts Road. Then, on November 4th, 2025, they rolled it out to the pad. By the next day, it was sitting on top of the flame trench. That is fast. In the old days, that kind of move would take weeks of planning and days of execution. SpaceX did it overnight. They are upgrading the tank farm too. These are the giant thermos bottles that hold the super cold fuel. Starship drinks a lot of fuel. It uses liquid methane and liquid oxygen. You need massive tanks to fill it up quickly, and you need a way to keep that fuel cold until the last second. The deluge system is another critical piece. When 33 Raptor engines light up, they produce 16.5 million pounds of. That is enough fire to melt concrete and turn steel into soup. You need water to protect the pad. A lot of water. The system sprays thousands of gallons in seconds. It creates a cushion of steam and water that absorbs the heat and noise. Without it, the pad would destroy itself every time a rocket launched. Engineers learned this the hard way. Early tests in Texas shattered concrete. Debris flew everywhere. It was a mess. They fixed it by adding a steel plate with water jets. They call it a water-cooled steel sandwich. It worked. The pad at LC-39A has a similar setup. It is built to take a beating and be ready for the next flight immediately. This focus on infrastructure is what separates SpaceX from everyone else. China is building big rockets too. Their Long March program is impressive, but they are still using the old method. They build a rocket, fly it, and throw it away. Or maybe they recover it nicely on legs, but they do not have a factory-like launch pad. They do not have a tower that catches and restacks. That puts them behind on the timeline. Russia is even further back. Their program relies on technology from the 1980s. It works, but it is expensive and slow. Blue Origin is building New Glenn. It is a big rocket, and it will land on a ship, but it is not flown yet. SpaceX is already flying. They are already landing, and they are already building the second and third generation of their pads. The gap is widening. Strategic positioning is huge here. Florida offers something Texas cannot. Starbase in Texas is great for testing, but it has limits. It is close to Mexico. It is close to populated islands. You cannot launch into certain paths from there. If you want to put a spy satellite into a polar orbit, you have to fly south. From Texas, that means flying over land. That is a safety risk the government won't take. Florida sticks out into the ocean. You can launch north, south, or east. You hit water immediately. immediately. That makes it perfect for military missions. It is perfect for secret satellites that need to circle the poles. That is why the Air Force approved SLC-37 for Starship. They need that capability. They need to know they can launch heavy payloads to any orbit anytime. The FAA numbers for SLC-37 confirm this. They approved 76 launches. That is a massive commitment. It tells you that the military sees Starship as a core part of their future. They are not just dabbling, they are going all in. They want the ability to put 100 tons of cargo into space whenever they want. Maybe it is new satellites. Maybe it is cargo for a moon base. The capability is the weapon. Think about the sheer volume of fuel involved. A single launch uses millions of pounds of propellant. To launch 76 times a year, you need a constant pipeline of methane and oxygen. You need power. You need logistics. It turns the Cape into an industrial hub. Trucks, ships, and pipes will be moving fuel 24/7. It creates jobs. It creates a supply chain that no other state has. Competitive scoreboard here that is worth watching. 2024, SpaceX launched nearly 100 times from Florida. That was mostly with the smaller Falcon 9. Now imagine replacing those with the tonnage to orbit goes through the roof. A Falcon 9 lifts about 17 tons. Starship lifts 100 tons or more. One Starship flight is like 6 Falcon flights. If they hit that 44 launch target at LC-39A, that is equivalent to hundreds of Falcon 9 launches in terms of cargo. It is mind-boggling. No other country can match that mass. It means SpaceX can build the Starlink internet constellation faster than anyone thought possible. They can put thousands of satellites up in a single year. That gives them a dominant position in communication. And this is where it gets interesting. The cost drops dramatically. If you reuse the booster and the ship, you only pay for fuel and ground ops. The hardware is free after the first few flights. That brings the price per ton down to numbers that sound fake, but they are real. It could cost less to launch a ton into space than it costs to ship a ton of cargo across the ocean by plane. That changes the economy of space. It makes things like solar power stations in orbit possible. It makes mining asteroids possible. It makes tourism possible. But it all starts with the pad. It starts with the tower that can turn a rocket around in a few days. That is the bottleneck. And Mechazilla is the solution. The team working on this is huge. It takes thousands of welders, engineers, and technicians. They work in shifts. The lights at the pad never go off. It is a 24-hour operation. You can see the progress if you drive by. 1 week, a section of the tower is missing. The next week, it is there. The cranes never stop moving. This is American industry at full speed. You also have to look at the near misses. It has not all been perfect. There have been tests where valves leaked. There have been times when the catch arms did not close fast enough in simulations. In Texas, they had boosters hit the water hard. They had ships explode upon landing. But each failure taught them something. They fixed the valve. They sped up the hydraulics. They reinforced the steel. This pattern of failing and fixing is what makes them fast. NASA usually spends years analyzing a problem before fixing it. SpaceX fixes it in days and tries again. It looks chaotic, but it is effective. The result is a system that is battle-hardened. By the time they start flying people from Florida, the system will have been tested hundreds of. The 2025 draft environmental impact statement is the green light. It sets the rules. It says, okay, you can do this, but here are the limits. The fact that there is a limit of 44 launches is actually good news. It means the government expects them to reach that number. It gives them a target. And knowing SpaceX, they will hit that target and then ask for more. The split between day and night launches is important too. Night launches are spectacular. The whole sky lights up, but they are also loud. People live nearby. The report acknowledges that. It puts measures in place to mitigate the noise, but it also accepts that this is the future. Florida is a space state. The rumble of rockets is the sound of money and progress. Let's look at the engines again. The Raptor engine is a beast. It is the most advanced rocket engine ever made. It uses a cycle called full-flow staged combustion. That is a fancy way of saying it wastes nothing. Every drop of fuel is burned to create thrust. It runs at insane pressures. Keeping 33 of them running smoothly next to each other is a miracle of plumbing and control. If one engine fails, the computer shuts it. The other engines adjust to keep the rocket straight. We saw this in flight tests. A rocket lost an engine on ascent, but it kept going. It reached space anyway. That redundancy is key. It means a mission can succeed even if things go wrong. That is safety through strength. The launch mount at SLC-37 will be even better than the one at LC-39A. They are learning from the first build. The new mount will be easier to fix. It will have better protection for the fuel lines. It will handle the vibration better. This is the advantage of building fast. You get to version 2.0 while everyone else is still working on version 1.0. The catch tower at SLC-37 will be taller too. The Air Force wants margin. They want to be sure that even if the booster comes in a little high or a little low, the arms can grab it. They are paying for reliability. And SpaceX delivering the dual tower setup at the Cape means they can have 2 rockets ready at once, one commercial, one military, or 2 military. It gives the president options. That strategic value is why the money is flowing. The government is not just buying rides. They are buying the infrastructure. They are investing in the pad because they know they need it. They saw what happened with Russia. They saw the rise of China. They know they cannot depend on old rockets forever. They need the big stick. Starship is the biggest stick there is. You might wonder about the noise. A rocket this big makes a lot of sound. The water system helps dampen it, but it will still rattle windows in Titusville. The EIS report studied this. They mapped the sound waves. They checked the impact on fish and birds. They concluded it is manageable. It is the price of admission for having the world's busiest spaceport in your backyard. The benefits outweigh the noise. The jobs are real. The contracts for local businesses are real. Concrete companies, steel suppliers, hotels, restaurants. Everyone benefits when the Cape is busy. It brings a tech boom to the area. Engineers move in. They buy houses. They pay taxes. It is an economic engine driven by rocket fuel. Competitors are watching this with worry. If you are a company selling launches on a small rocket, this is bad news. How do you compete with a giant reusable ship? You can't. You have to find a niche or go out of business. We are seeing a consolidation. The market is moving toward heavy lift. Satellites are getting bigger because they can. It is cheaper to build a heavy, rugged satellite than a small, delicate one. SpaceX is driving this change. They are not just meeting demand, they are creating it. By making launch cheap and frequent, they invite new ideas. Maybe someone wants to launch a giant space telescope. Before, it was too expensive. Now it fits in one Starship flight. Maybe a university wants to send a probe to Neptune. Now they can afford it. The operational rhythm is the final piece. Crews know exactly what to do. The checklist is memorized. It becomes boring. And boring is good. Boring means safe. Boring means reliable. When a launch is a special event, everyone is nervous. When it is just another Tuesday, mistakes go down. Mastery takes over. The FAA report mentions 44 booster landings. That means 44 sonic booms as the booster comes back. People will get used to it. It will be like hearing a train go by. It signals that work is being done. The return to launch site is critical. If you land on a ship at sea, you have to tow it back. That takes days. Landing at the pad takes minutes. That is why the tower catch is so vital. It cuts out the boat ride. It keeps the hardware at the factory. It allows for that rapid reuse. Rapid is the key word. Elon Musk talks about flying the same booster twice in one day. We are not there yet, but flying it once a week is very possible with this setup. The flame trench at LC-39A is historic. It handled the Saturn V. It handled the shuttle. Now it handles Starship. They had to strip it down and rebuild the deflect. The heat is more intense now. The exhaust is cleaner. Methane burns clean, but it is hotter. The engineering that went into retrofitting the old trench is impressive. It is a blend of history and future. So where does this leave us? We have a government report that says 44 launches a year is okay. We have a military approval for 76 more. We have a tower that can catch rockets. We have a factory pumping out engines. The pieces are all there. The machine is being assembled. The first Florida flights are targeted for mid-2026. That is right around the corner. By then, the testing in Texas will have ironed out the bugs. Florida will inherit a proven system. They won't be experimenting, they will be operating. That is a huge difference. SpaceX has turned the impossible into the inevitable. They took a concept that sounded like science fiction, catching a building-sized rocket with chopsticks, and built it in steel. They navigated the bureaucracy to get the permits. They built the supply chain to feed the beast. The result is a capability gap that no other nation can cross right now. While others are drawing plans, SpaceX is pouring concrete. While others are testing small engines, SpaceX is firing 33 big ones. The lead is measured in years, maybe decades, and it all centers on that tower at LC-39A. It stands there as a symbol. It says that we are not done going to space. We are just getting started. The pace is about to pick up, the roar is about to get louder, and the sky is about to get a lot busier. This is what mastery looks like. It is not just having a good idea. It is building the machine that makes the idea real. It is sweating the details on barge transport and bolt alignment. It is fighting for the permits. It is doing the hard, boring work that makes the magic. LC-39A is ready for its next chapter. The hardware is stacked, the fuel is cold, the plans are approved. Soon you will see the fire, you will feel the shake, and you will know that the future has arrived right on schedule.